Hello everyone, and welcome to another session. In this class, we're going to review 3 questions. They are questions we've done before, but they were a little while ago. And the reason we're doing them again, quite simply, is because today we will be doing computer solutions. I want you to concentrate on the computer solution, not necessarily the translation from natural language into equation format. For that reason, we are looking at problems that we've solved before in the past. The other additional reason is I want to make sure everybody is able in some way, shape, or form to check their answers. And if they're questions we've done before in the past, it should be relatively easy for you to check your answers. So let's begin. A doctor tells a sick freshman to add bananas and oranges to his diet for vitamin A, vitamin B, and vitamin C. This is a question that we did look at. It's a question that focuses on finding the ideal situation to minimize cost while still ensuring that the student has enough of each vitamin group, A, B, and C. In this situation, we have 2 decision variables, oranges and bananas. We also have 3 constraints. We have we have 5 constraints. We have a minimum amount of vitamin A, a minimum amount of vitamin B, and a minimum amount of vitamin C. We also have a maximum amount of vitamin A and a maximum amount of vitamin B. So we have a total of 5 constraints and 2 decision variables. We see those here. Minimize z equals 350x1 plus 540x2, subject to 8x1 plus 2x2 is greater than or equal to 23, and that's our minimum amount of vitamin A. 6x1 plus 6x2 is greater than or equal to 37. That's our minimum amount of vitamin B. 2x1 is greater than or equal to 6, and that's our minimum amount of vitamin C. 8x1 plus 2x2 is less than or equal to 50, which is our maximum amount of vitamin A. And 6x1 plus 6x2 is less than or equal to 70, our maximum amount of vitamin B. With this question, the translation from this stage to this stage should, at this point, be very easy for you. It should be something that you don't struggle with in any way. Because as we continue, the questions will get more difficult. This is a very base level translation from natural language to equation format. So hopefully everybody is not struggling with that. We have solved this problem in the past, so you do have it available. But if not, you can look at this information here and hopefully without too much trouble get to this information. So from here, now we're going to move into both Microsoft Excel and then QM solving this problem. Let's do that now. So here we have a Microsoft Excel spreadsheet. We've seen this before. If we click here on data, I do have the solver installed. We can see that on the far right-hand side. But for now, we'll just go to home. We'll call this the vitamin example. Our first step is entering this information, our title. Then, in this area, I'm going to write products, but we can also write choices. And our first choice, we'll make these a little bit wider. And this is only for simplicity's sake. It is not necessary. Our choices are oranges and bananas. Now here, because it's a minimization, we're going to call it cost. And for some reason, I'm getting a strange reaction with my keyboard, but that's okay. Oranges, the cost of oranges, we saw from our equation, is $3.50. Our cost for oranges, $5.40. This is drawn from this information here. That's where we're pulling this information. It comes from our objective function. So we go back now to Excel. Our next stage is to mention our resources. The first one is min vitamin A. This is where we're inputting essentially all of our constraints. The second one is min vitamin B. The third is min vitamin C. And we also have max vitamin A, max vitamin B. This information can be found here. One more time. We've got this key information here. Now we have to enter our critical information here. So we come up to Excel. Now I have a copy of this in front of me. I cannot switch back and forth every 2 seconds, but I do recommend that in this situation. So for every orange, we get 8 units of vitamin A, and we get 2 units of vitamin B. From bananas, we get 2 units of vitamin A. If we move on to vitamin B, we get 6 units for oranges, 6 units for bananas. If we move on to vitamin C, we get 2 units for for oranges, and 0 units for bananas. We can leave this empty, or we can write in the 0. Both are okay. Neither will affect our final solution. So we come down here, and again, for our maximum for vitamin A, we get 8 units for oranges, 2 units for bananas. With vitamin B, we get 6 units for oranges, 6 units for bananas. This is where we've entered all of our constraints so far. From the last time, hopefully you remember that we have here usage. But before we can enter our usage, in this situation, our usage equations, we have to come down here. Now it doesn't matter where we go. I could type over here if I wanted. But the key is when we enter our formulas in the solver, we have to pay attention to which cell and which formula is in which. So for now, we'll just go right here and we'll put choices, oranges, bananas. Both of these will remain at 0 because this is what the computer will solve for us. It will run different permutations of our problem until it's able to solve this for us. So we come up here, usage is equal to find our usage, we want to multiply the number per oranges times the number of oranges plus the number per banana times the number of bananas. That's the formula we'll enter now. So equals the amount per orange times the number of oranges plus the amount per banana times the number of bananas. Right now it's 0 because we have no oranges and no bananas. But as the computer works through permutations, these numbers will change. As they change, these numbers will also change. So we're going to continue entering our formula. So equals the number per orange times the amount of oranges plus the number per banana times the number of bananas. One more time. And we do it 2 more times down here. I'm not going to explain because I have already. Please wait 1 second. So this is, now we've entered all of our usage statistics. Now, as I said before, we're going to very simply just add something. This column doesn't matter. This is entered meaningfully into the solver equation. But for comprehension's sake, we'll say it has to be greater than or equal to, greater than or equal to, greater than or equal to, less than or equal to, less than or equal to. That's what we've done so far. And over here, the available column. And this is where we enter our relevant data. We require a minimum of 37 grams of vitamin A, or sorry, 23 grams of vitamin A, 37 grams of vitamin B, 6 grams of vitamin C, and we have a maximum of 50 grams of vitamin A, 70 grams of vitamin C. So we've essentially completed what we have to do so far. We have one more. I'm going to go down here and put total cost, because in this situation it's a minimization and we're trying to minimize our total cost. How do we find total cost? Because that's the formula we have to enter here. Total cost will be the number or the cost per orange times the number of oranges plus the cost per banana times the number of bananas. Right now it will be 0 because we have no, I made a small mistake here. Okay, times the number. Now it will be 0 for both. Our total cost will currently be 0 because as of right now, we are buying no oranges and buying no bananas. So in this situation, it will remain at 0 for now. But as the computer runs permutations and it tries different combinations of oranges and bananas, our total cost will fluctuate. The computer will keep trying combinations until it satisfies our constraints right here, our minimums and maximums. But it will do this at the lowest possible cost. Right now, the cost is 0, but none of these are satisfied. So, in that situation, we have to continue changing. Now, I can manually change this. If I make this 1 and 0, now we have, because we have 1 orange, we have 8 grams of vitamin A, 6 grams of vitamin B, 2 grams of vitamin C, 8 grams of vitamin A, 6 grams right here. We're multiplying each of this times 1. That gives us these totals. But this still doesn't satisfy. So instead of us manually changing it, 1 and 1, 2 and 1, 2 and 2, instead of us manually changing these, we're going to allow the computer to do that. So we'll make that 0 for now, and 0 for now. But what I want to do now is I want the computer to enter, to run different permutations of this. So to tell the computer how to do that, I come up here to Data, and I click on my solver function. Our set objective is found in square, not B16, but in square B17. That's where our final objective is to minimize the total cost. So we want this square, B17, to be minimized. So I click on minimize. B17 must be minimized. Which cells am I going to experiment with? What cells am I going to run permutations? Very simply, cells B14 and B15. This is where I will end. The computer will start with 0, 0. It will move to 1, 0, 1, 1, 2, 1, 2, 0, etc. until it finds our optimal solution. But we do have constraints governing our choices. We enter those here. Our first constraint, we add, this usage must be greater than or equal to 23. A second one, our usage of vitamin B must be greater than or equal to 37. Number 3, our usage of vitamin C must be greater than or equal to this column, F8, which is 6. Now we're changing it a little bit. This number must be greater than or less than or equal to 50. And the last one, this column, which is our usage of vitamin B, must be less than or equal to 70. We hit OK, and all 5 of our constraints have been added. We come down here, always change it to simplex LP, and then very simply we hit solve. Solver found a solution. All constraints and optimality conditions are satisfied. We hit OK. And what we found is our optimum choice is to choose no bananas at all. We want 6.1666 repeating oranges. If we do that, if we choose this, we get 49.33 grams of vitamin A. That's enough, but not too much. Enough, but not too much. We get 37 grams of vitamin B. That's enough. 12.33 grams of vitamin C, which is enough. And its vitamin B still remains lower. This is the minimum amount we can get, which also keeps our total cost minimized at $21.58. There are other choices that will satisfy our constraints, but this is our cheapest choice that will satisfy constraints if we want to minimize our costs. So once we've solved it here in Microsoft Excel, we're going to solve it one more time in QM for Windows. So let's go to that program now. Here's QM for Windows. To begin, we click on Module, Linear Programming, and we open a new file. We're going to title it our vitamin example. We have 5 constraints we know, and we have 2 variables, and we're also trying to minimize. Once we click through, this becomes very easy. We come down here, it's our vitamin example. Our first choice is oranges. Our second choice is bananas. The cost of oranges is 3.50. The cost of bananas, 5.40. Our first constraint, minimum vitamin A. Our second constraint, minimum vitamin B. Our third, minimum vitamin C. And then to reverse it, max vitamin A, max vitamin B. So our minimum for vitamin A is 8 units, and we know this from when we translated to the equation format. 2 units per banana, and it must be greater than or equal to 23 units. We know we get 6 units per orange of vitamin B, 6 units per banana, and we have a minimum requirement of 37 units. For vitamin C, we get 2 units, 0 units, and it must be greater than or equal to 6. One more time, we come down to max vitamin A, and very simply, we repeat 8 units for an orange, 2 units for a banana, must be less than or equal to 50. It's important to remember that we have to change our signs here. One more time, 6 units, less than or equal to 70 total units. So here we are, and we've successfully completed our problem formulation. From here, very simply, we hit solve, and we see that we should buy 6.17 oranges. In the last one, it was 6.166667, so the answer is identical. No bananas, as we can see here. And our final cost, which is the right-hand side equation, will be $21.58. That's what we've shown here. We've successfully solved this problem in 2 different ways, using Microsoft Excel and using QM for Windows. For now, we're going to do one more quick example because I want everybody to be comfortable with these easy examples for now. So let's come back here to our next example, which is the pizza problem, a manufacturing problem. You own a manufacturing company that needs to choose how many phone cases and how many chargers to manufacture. You know that you have 64 hours of labor available and 48 kilograms of supplies available. You have each case requires 8 hours of labor and 2 kilograms of parts to produce. You also know that you require 4 hours of labor and 12 kilograms of parts to produce a charger. You make $12 per case sold and $32 per charger sold. However, you don't know how many of each to produce to maximize revenue. So you must determine that with linear programming. Again, we've solved this problem, so we're going to skip a step, several steps, and we'll go right here to our problem formulation. This problem is even easier than the last one. It's the sort of problem that you should have absolutely no issues with. It's very straightforward. It's something we've seen again and again, and it should be something that you guys, as you've progressed, have developed the skills necessary to solve to completion until now. Because this will become more difficult, our problem formulation, but it is the problem formulation that becomes critical as we become more comfortable using Excel and QM for Windows. So, to begin, let's go into Excel. We're going to open a new file, a blank workbook, and we'll title it our charger case problem. We'll make our columns a little bit bigger. And again, this is just for simplicity's sake. So our first step is mentioning our choices. The first one is charger. The second is case. In this situation, we know from the problem that we're dealing with revenue. So we check here, and we see we make $12 per charger and $32 per case. So charger is 12, case is 32. The beginning steps of Microsoft Excel are all about setting up the problem effectively in the spreadsheet. Now, when we have very simple problems like this, it's much easier to use QM for Windows. However, when we move into much more difficult problems, Microsoft Excel can be preferable to QM. But for now, it probably will be easier in QM. However, I do recommend you solve it in both. For your homework assignments, you will have to solve in both. For the final exam, you will have to solve in both. And it's not only good practice, but it's a useful skill to develop as well. So once we've entered this information, now we're going to go down and enter our resources, which is another word for constraints. The first one that we have is labor, and the second, supplies. So coming over here, for a charger, labor is 8 hours. A case is 4 hours. For supplies, a charger is 2 units and a case is 12 units. This information is essentially our constraints as we found them earlier. And then we move on to usage here. However, as I said before, until we've chosen where we're going to instruct the computer to run permutations, we can't write our formulas in. So we'll do that here. The first one is chargers. The second, cases. Now we have this information. We can enter our usage formula. So the amount of labor we use is equal to the labor per charger times the number of chargers plus the labor per case times the number of cases. And we do that one more time. To determine the total usage of supplies is equal to supplies per charger times number of chargers plus supplies per case times the number of cases. Right now, again, as before, it will be 0 because it is in these places that we need chargers and cases to be manufactured before we can determine usage. Okay, we have one, we're going to come over here and we're going to say it must be less than or equal to, because these are manufacturing problems. And we have a maximum amount of labor and supplies available of 64 units and 48 units. So we come down here, we have one more formula to enter down here, and that will be our total revenue. And to find our total revenue, we multiply the amount of revenue we make per charger, which is here, times the total number of chargers, plus the amount of revenue we make per case, times the total number of cases. And that we find here. Right now it will be 0. It will remain at 0 because in this situation we have yet to manufacture any chargers or any cases. So of course our revenue at the moment will be 0. So we've successfully entered all of the relevant data. We've successfully entered our formulas. Our next step to solve involves opening the solver program and allowing the computer to solve this problem for us. So we click on the Data tab. On the far right, we click on Solver. Our set objective is not A16. Our set objective is where we've entered our total revenue formula. That's B15. Last time we minimized. This time we're going to maximize. Which cells are we running permutations of? Quite simply, B12 and B13. As I said, right now, this is relatively easy. It's B12 and B13 because we only have two decision variables. This is an intensely easy example. In the future, we may have 3, 4, 5, 15 decision variables. In that situation, we need to be aware that we're selecting all of those cells to be changed in that situation. So now we have to add our two constraints. The first one, the labor used, which is D7, must be less than or equal to the labor available, which is F7. We can hit OK and add a new one, or we could just hit add. Both are OK. So our second constraint is D8, which is our usage of labor supplies, must be less than or equal to F8, which is our total amount of supplies available. We click OK. We have both of our constraints written here. We go to Simplex LP, and now we've entered all of the relevant data. We have all of the formulas inputted. We've entered everything properly in our solver function. So our only solution now is to hit solve. Solver found a solution. All constraints and optimality conditions are satisfied. Oh, something happened. 1 second, please. Oh, I know the solution is it automatically changed to book 1 instead of remaining in book 2. So all it did was change back to my previous Excel page, which again right here was the problem we just solved. So I stay on page number 2 and we found our new optimum solution. We should produce 6.55 chargers, 2.91 cases. If we do that, given the resources we have, we will maximize our total revenue at $171.64. This is the solution found through Microsoft Excel. Let's solve it one more time in QM before we move on. So we come over to QM. We click on Module, Linear Programming. We want to open a new file. We have, our title is Charger Case Problem. We have two constraints and two variables. It's a maximization. So very simply in this stage, all we do is hit OK. Our first one, chargers. Our second, cases. We're maximizing if it's $12 and $32. Constraint number 1 is labor available. Constraint number 2 is supplies available. Labor available is, in this situation, very simply, 8 units per charger, 4 units per case, and it must be less than or equal to the 64 hours of labor we have available. Oh, Down here, our supplies, we have 2 units per charger, 12 units per case, and we have total of 48 units available. So very simply, this was an easy problem. There were only 2 constraints and there were only 2 variables. So it's a very simple to enter the data here into QM. We hit solve right here and we see an identical solution. Because we've solved it in 2 different problems, 2 different programs, we know most likely, because we have identical answers, that these are the correct answers. We should produce 6.55 chargers. We should produce 2.91 chargers. And that will give us a total of 171.64 units. All right, everyone. Your work today, now that I've solved those 2 problems, is to move on here to practice problem number 3. This is a pizza restaurant. You've just received an order for 100 pizzas tomorrow. However, tomorrow is a holiday, so you're currently out of supplies, etc. I would like you to solve this problem. I will leave it on the screen for the next 9 minutes. At the 45-minute mark, I will address the class. I would like you to solve this problem using Microsoft Excel and QM for Windows to practice the skills you will need in the future. Good luck solving these. I will address you at the 45-minute mark of this video. Okay, thank you for watching, everyone. Hopefully you have no questions, but if you do, as always, you can contact me. This is similar to what we'll be doing in the future, so hopefully these basic questions aren't causing too many problems. If you do have problems, as always, let me know. Thank you again. Have a wonderful day.